In this session, we will see about simplification of a Boolean expression using kmap. In the last session, we have discussed about 2 variable, 3 variable and 4 variable kmaps. So, as a first step for simplification is mapping. That is, we have to map the given expression into the kmap. We have to map the given expression into kmap. Let us see an example. Consider the expression a bar, b bar, c bar plus ab, c bar plus abc. Actually, this expression is formed by 3 variables a, b and c. So, we need to draw a 3 variable kmap. If you are not familiar in drawing 3 variable kmaps, go and watch the previous video. A bar, b bar, c bar means it is 0, 0, 0. This is 1, 1, 0 and this is 1, 1, 1. You can also write here as this is a bar, b bar. This is a bar, b. This is ab and this is ab bar. Here this is c bar and c. So, when we map, first one is a bar, b bar, c bar or 0, 0, 0. This is the first step. 0, 0, 0 or a bar, b bar, c bar. Row is a bar, b bar and the column is c bar or 0, 0, 0. Next is 1, 1, 0. 1, 1, 0 lies here. This is 1, 1, 0. Next a, b, c all are 1. 1, 1, 1 is this one. This is how we map an expression to kmap. We have mapped this expression to 1. Each term, each product term is mapped to 1 because this is a SOAP expression. Since this is a SOAP expression, sum of products, we are mapping to 1. Each product term or min term is mapped to 1. This is how mapping is done. This equation can be also written as, this expression can be also written as sigma m of 0, 6, 7. This 0, 6, 7 represents these numbers. 0, 0, 0 is decimal 0, 1, 1, 0 is decimal 6 and 1, 1, 1 is decimal 7. So, if something is given like this, sigma m of 0, 6, 7, that means sigma means sum, m is min term or product term, sum of min terms 0, 6, 7. Sigma m means sum of min terms 0, 6, 7. That means 0 is 0, 0, 0, that is a bar, b bar, c bar, plus 6 is 1, 1, 0, that is a, b, c bar, plus 1, 1, 1 is 7, that is a, b, c. So, SOAP expression is written as sigma m of min terms. So, we know the cell numbers as discussed in the previous session. This is 0, 1, 2, 3, 4, 5, 6, 7. These are the cell numbers. We will put 1 in the corresponding cell numbers. Cell number 0 we have already marked as 1. Cell number 6 we have already marked as 1. Cell number 7 we have already marked as 1. So, questions may be asked either in this form or in this form. We will see another example, that is sigma m of 0, 1, 7, 8, 11, 14. Here 14 is a decimal number and the corresponding binary number is 1110. The largest number is 14. This is 1110. That is 4 bit is required to represent 14. Maximum number is 14 and it requires 4 bit, 4 binary bit to represent 14. Therefore, we require a 4 variable kmap. Therefore, we require a 4 variable kmap. I am going to write the variable values also. This is a bar, b bar, a bar, b, a b, a b bar. This is c bar, d bar, c bar, d, c d, c d bar. We can write the cell numbers also because it is given as min times, the numbers. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now we will mark 1 because this is sum of min times, that is SOAP expression. Sum of min times is SOAP expression. Since it is SOAP expression, we have to mark or map as into 1, map to 1. So 0th cell, this is 0th cell, that is mapped. Then first cell, this is 1. Then 7th cell, this is 7th cell, 8th cell, 11th cell and 14th cell. So this is how you map this given question to the kmap. Or you can also find the expression of for this given question. You can also find the expression. So to find the expression, first we will write the corresponding binary value. 14 is 1110. Since 14 is in 4 bit, we will write everything in 4 bit. 11 is 1011. 8 is 1000. 7 is 0111. 1 is 0001 and 0 is 0000. So we can write the expression. What is 0000? In the previous question also we have written this. 000 means A bar, B bar, C bar. If 0 is there, we have to put a bar. So 0000 is A bar, B bar, C bar, D bar. Since 4 variables are there, we have to include D also. Plus next one. This is A bar, B bar, C bar, D is 1. So we have to put as D. Next is A bar, B, C, D plus A, B bar, C bar, D bar plus for 1011 it is A, B bar, C, D plus A, B, C, D bar. So questions can be asked in either form. Either they may give as this expression or they may give as sigma of min times. In both the case, we can map like this. If it is in the case of expression, we can directly map A bar, B bar, C bar, D bar is the first cell. Row is A bar, B bar and column is C bar, D bar where you can mark 1. Similarly, A bar, B bar, C bar, D, that is the second column. Oh, sorry, second cell. So this is also, this method also we can map, and if it is given as sigma of min times, we can directly map to the corresponding cells. This is how you map a given expression to kmap. We will see one more example for mapping, that is for pose expression, that is A plus B plus C into A plus B bar plus C into A bar plus B bar plus C. Again, we can write two binary values. This is 1, not 1, this is 0, 0, 0. In pose expression, if there is no bar, then it is 0. If there is bar, it is 1. Into here it is 0, 1, 0. B is having a bar, therefore it is 1. And here A is having bar 1, B is having bar 1 and C is having no bar, so it is 0. So these are the corresponding values 0, 0, 0, 0, 1, 0, 1, 1, 1. So as in the last case, pose expression can be also be written as, or the question can be given as pi of, pi means product, the product of some time, that is product of max time, capital M. We have already seen in the previous videos, in pose expression, the sum time is known as max time. That is A plus B plus C is one max time, this is another max time, this is another max time. Sum of max time of 0, 0, 0 is 0, comma, 0, 1, 0, in decimal it is 2, comma, 1, 1, 0 is 6. So this is how max time is represented. Whenever you see pi or capital M, it is a pose type. It is a pose expression. So again we need how many variables are there? 3 variables. So we need a 3 variable kmap. So when you map, you can write the cell numbers 0, 1, 2, 3, 4, 5, 6, 7. We have the cells 0, 2 and 6. So we have to map to 0, not to 1. In pose expression, we have to map it to 0. So the next value is 2. The next cell is 2. So 2 is here. We will put the 0 here. And the next one is 6. We will put 0 here. So this is same as if we write the value in variables. This is a plus b. This is a plus b bar. This is a bar plus b bar. And this is a bar plus b. This is c, c bar. So this cell is a plus b plus c. This is this one. Second one is this and third one is this. This is how we map a pose expression to a kmap. After mapping, the next step is grouping. Grouping means grouping the cells. Grouping the cells. While grouping, we have to consider some conditions. First condition is a group consists of one cell, 2 cells together, 4 cells, 8 cells, 16 cells. In a group, we can have a single cell, 2 cells, 4 cells together, 8 cells together, or 16 cells together. We can also have 32 cells together when we consider the 5 variable kmap. And another thing is, these cells which are in a group, the cells which are in a group must be adjacent cells. Adjacent cells. We will see about the adjacent cells when we group in kmap. And another thing is, we have to consider the largest group. That means we have to take the group with maximum number of cells. Otherwise, we will not get a simplified expression. So we have to consider the largest group. And another thing you have to remember is that while grouping, you have to use either a rectangle shape or a square shape. You are not allowed to use any other shape to group the cells, any other shape like this. So these are the things you have to keep in mind while grouping. So we'll see some examples. Consider the expression sigma m of 0, 1, 2, 5, 6, 7. I have given as sum of min times. So this is a SOAP expression. If we need, we can write this in terms of variables, like 0 is, since this is a SOAP expression, 0 is a bar, b bar, c bar, plus a bar, b bar, c, plus 2 is a bar, b, c bar, that is 0, 1, 0. Isn't it? We have to, if we need, we can write the corresponding decimal number also, binary number also, that is 0, 0, 0, 1 is 0, 0, 1, 2 is 0, 1, 0, plus 5 is a, b bar, c, that is 1, 0, 1, plus 6 is a, b, c bar, that is 1, 1, 0, and finally 7 is a, b, c, that is 1, 1, 1. Since for representing 7 in binary we need 3 bit 1, 1, 1. So 3 variables are required. You have to take the maximum number and find number of bits required to represent it, and that's the number of variables. So if we draw the kmap, first we have to map this to the kmap. We need 3 variable kmap. So this is the 3 variable kmap. We can also number the cells. So I am going to numbering the cell. That is, this is 0, 1, 2, 3, 4, 5, 6, 7. Now you have to map the corresponding cell. Since this is SOAP expression, you have to put 1 in the corresponding cell. That means cells 0, 1, 2, 5, 6, 7. 0, 1, 2, 5, 6, 7. Now we have to group as per the rules. The condition is we have to group all the ones. We have to group all the ones. In SOAP expression, we have to group all the ones. In POSE expression, we have to group all the zeros. So these are the 3 conditions. So first we will check at the top 2 ones. So when we consider the top one, in the right side we have one that is the adjacent cell. In the left side we have nothing. Actually the left side is same as the right side. When we fold this like a paper vertically, the left side of the portion will come this one, the right side, when you fold a paper vertically. So this is adjacent, and when you fold the top and the bottom, when you fold a paper horizontally, the top cells and bottom cells are adjacent. You can see here in this figure, actually this figure is a 4 variable kmap. You can fold horizontally and vertically. So this is something which is folded vertically. You can see the top row, that is the 0, 0, the 0, 0 row and 1, 0 row. When they are folded vertically, these two become adjacent. When these two touches, this 0, 0 and 1, 0, the top row and the bottom row become adjacent, like the intermediate rows. When you fold it like this, like a cylinder, then that will be adjacent. So the top row and the bottom row are adjacent. Similarly, when you fold it vertically, you can see the last column and first column will become adjacent. When you see the 4 variable kmap, you can use it. When you fold it, it is like this. So keep this in your mind. The top row and the bottom row are adjacent rows. The first column and the last column are also. If that the case, we can see how to group this. Consider this one, first one. Right side there is a 1, bottom side there is a 1, and in the top side, top means the bottom one, bottom side. Here there is nothing. So we have 2 options: either group these two or group these two one. We can choose any two, but the better option is to group these two. You will came to know later why I choose these 2 ones in a group. So next group size is 4. We cannot have 4 ones together, adjacent ones together. That's why I chose 2 1. So the next group I can choose these 2 1 together. This is another group, and finally I can choose these 2 1 together. So these are the 3 groups. Now I will give some more examples for grouping so that you can be familiar. So I will draw the kmap. I will draw some kmap, and we can try to group it. So keep the rules in your mind while grouping. So I am not going to write all those stuff in every kmap. So these are the mapped kmap, and I haven't written any expression, just for getting familiarized with the grouping and giving some sample problems. So how to group this kmap? Here if we consider this one, there is nothing in right side, there is nothing in top, there is nothing in bottom. So no adjacent one is available in the neighboring cells. Therefore, we have to group it as a single group, because we can group as a single cell in kmap. You can see here. We can group as 2 cell, 4 cell, 8 cell and 16 cells. So this one we can group it as a single cell. Now next, the second, consider this one, whether anything is there in the adjacent cell. The bottom it is, there is nothing. Left side there is nothing. Top means bottom. Yeah, here there is one. Therefore, this one and this one form a group. That means when you fold it vertically, you can imagine, or you can take a piece of paper, and when you fold it vertically like this, when you fold it vertically, this and this join together, and you will get these two one in adjacent rows. When you fold vertically, this 0 0 row and 1 0 row will touch each other, and this row and this row will be adjacent to each other. So when you group the boundary cells, you have to draw the shape like this, the open bracket like this and the bottom like this. So we will see another example. So this is another one, another for variable. So how to group this? First, if you consider this one, we have 4 adjacent ones, or 4 adjacent cells have 1. So we can group all these 4 cells together. And when we look at the bottom one, again here 4 adjacent cells having ones are together, so that we can group together. And here we have 3 choices. Either this one can be grouped alone, or this one can be grouped. There is nothing in the right side and left side, but at the bottom and top we have one. But we cannot group these 3 ones together, because 3 cells is not a valid group size. You have here the valid group size is 1, 2, 4, 8 and 16. So these are the valid group size, or number of cells inside a group. These are the valid number of cells inside the groups. So either we can have 1 cell, or we can have this one can be grouped with this one to form a group of 2 cells, or this one can be grouped with this one. Which one will we prefer? So we prefer the biggest group. We prefer the largest group. It is written here. We prefer the largest group. That is group with the maximum number of cells. So we can avoid this one. We can avoid this one. That means single one. A group with one alone we can avoid, because we can group this one with the 2 cells. So 2 is larger than 1. A group with the 2 cells is larger than group with a single cell. So we can take either of this one group. We don't need two groups together. We can take either this one. So I am going to delete one. So our aim is to group all the ones. A single cell can be a part of different groups. That's not a problem. Single cell can be a part of different groups, but each one should be grouped. Each one should be a part of in any group, at least in one group. Each one should be a part of at least in one group. Either you can take this one, or you can group it this one with the bottom one. Both are fine. So we will see another example. So this is another example, how to group. Here, by looking into it, we can easily tell that these 8 cells are adjacent. That is a valid group size. So this can be grouped together, 8 cells. Now at the bottom 2 cells are having 1. Either we can group these two one together, or there is another choice. We can take these two and at the bottom, that means top cell, top two together to form a group size of 4. 4 cells together in a group. We cannot take these two also because 6 is not a valid group size. So these two and the bottom two, that means the top two are adjacent to each other. Therefore, that is the biggest group. So we are not interested in this small group of having 2 cells. We are interested in having larger group. Therefore, these two and these two can be formed as a group to form a bigger group. We will see another kmap now. So this is another kmap. How to group this? First, we will consider the rightmost one. So there are 2 possibilities. You can group these two, or I am going to group this with the bottom one. There is no other option. There is nothing in left. There is nothing in right. Right means this one. The right of this means when you fold, this is the right side. So there is something in bottom also. Here there is a 1. Either I can group these two, or what I have done just now. So since this one is alone here, I am grouping this with this one. So that's the better choice. These 4 are together, so I am going to group these 4. Now these two 1 can be grouped together with the top 2 ones to form a group of 4. And now the bottom 1 can be grouped with, we have nothing in right, we have nothing in bottom. Bottom means the top, nothing is here. So we have 2 options. We can either group with the top 1 or with the right one. Anything one is enough. We have 2 choices. So I am going to choose the first one. So now all the ones are grouped. Our aim is to group all the 1. And another thing you have to take care is, we should group all the ones with minimum number of groups. The number of groups should be minimum. That's why I told we have to choose the maximum bigger group. The biggest group, we have to give preference to the biggest group. Then only the number of groups will be minimum in number. So number of groups is small. We will see another example. So this is another example, how to group this. So this one, first I will start with this one. This one is standing alone. So left side there is nothing, top or right nothing, only this one is here. So no other choice, I have to group like this. Now this one is, these 2 ones are grouped, leave it. Now this one can be grouped like this or this. So if I group like this, maximum 1 can be covered, or we can, we will see, we will group like this. These 4 1 can be grouped. We can group in different ways. The only thing is, we need minimum number of groups. We may have different answers. And another, these 2 1 can be grouped with these 2 1. And next, these 2 ones can be grouped like this. So total number of groups is 1, 2, 3, 4 groups. Total 4 groups. We will see another example. So in this case, I am going to, okay. Now in this case, you have to consider one thing. If we fold both horizontally and vertically, you have to imagine, if you fold both horizontally and vertically, the corner 4 cells come at the center, like this one. The corner 4 cells will come at the center, and they are adjacent to each other. and they form a group. You can imagine if you fold horizontally and vertically together, then these 4 cells will come at the center. So they form a group. And the other group is the center 4 can be formed to another group. So this is some of the exceptional cases you have to think about it. The 4 corner cells can be grouped together. We will see another example. So this is another example. How to group this? You try it by pausing the video and later come back. So this one, at the top there is nothing. That means top means bottom, there is nothing. Left side means right side, there is nothing. For this one, top, here nothing, here nothing. Top and left side nothing. So only thing is there is right side, there is a 1, we can group. Now for this one, we have 2 options. Either we can group it with the bottom one, or we can group that one with the bottom one, top one. So whichever method we need, we can use it. So I am going to group these 2. Now this one, there is no other way. We only left side there is a 1. We have to group it. Now here also these 2 1 are staying alone. There is nothing in the top, left, right, bottom. And finally the last 2 1 can be grouped together. No way of having 4 cells. After 2, we have to group with the 4 cells. There is no other option. So total number of groups is 1, 2, 3, 4 and 5. If anybody is getting less than 5 groups, then that will be the correct answer. You have to group according to the rules. But for me, it's 5 groups. I am not getting any other answer. I need 5 groups to group all the ones. So this is how we group kmap in 3 variable or 4 variable. So now we will see to simplify, how to simplify a given expression using kmap. So we will see this in the next video.